everyone, welcome back to the new lecture. So in this lecture we are going to discuss about refrigerants. So let's start. After the end of this lecture you would be able to understand introduction to refrigerants and its type. Then we'll discuss about the refrigerant properties and then the selection criteria of refrigerants. So now, first of all, we'll discuss what is the main purpose of refrigerant. Okay. Refrigerants are substances used in refrigeration cycle to absorb heat from one area and release it to another, thus cooling a space or maintaining a specific temperature. They play a critical role in HVAC system and other refrigeration technologies such as refrigerator and freezer. And here you have to remember one point, the performance and efficiency of HVAC systems largely depends on the properties of the refrigerant used. Okay, which type of refrigerant you are using. As per that, totally depends the performance and efficiency of HVAC depends on the properties of the refrigerant use. Okay. Now here we'll discuss about the types of refrigerant. So here remember, refrigerants are categorized based on their chemical composition, environmental impact and application. Okay. The most common types are different types of refrigerants are there, like chlorofluorocarbons. Okay. Then hydrochlorofluorocarbons, hydrofluorocarbon. Okay. So that all we'll discuss one by one. So in that, the first one is chlorofluorocarbon. In short, you can say CFC. So what is this? Try to understand. Chlorofluorocarbon were widely used in refrigeration and air conditioning systems during the mid 20th century. Okay. They contain chlorine, fluorine and carbon and are stable, non-flammable and non-toxic. Now if we discuss about the environmental impact of chlorofluorocarbon, so remember this CFC have a significant role in the depletion of the ozone layer, which protect the earth from harmful ultraviolet radiation. Even chlorofluorocarbon also have a high global warming potential, contributing to global warming. Okay. So that is why here it is given this type of refrigerant were commonly used in older HVAC system, refrigerator and aerosol spray. Okay. And here remember this chlorofluorocarbon including R2L were completely phased out under the Montreal Protocol due to their harmful effect on the ozone layer. So they are now banned in most countries. Okay. So remember this point also. Now the second types which we have to discuss here is hydrochlorofluorocarbon. In short, HCFC. See what is this? HCFC are transitional refrigerant introduced to replace chlorofluorocarbon. Okay. They contain hydrogen, chlorine, fluorine and carbon, which make them less stable and less harmful to the ozone layer than CFC, means chlorofluorocarbon. So here the environmental impact of this hydrochlorofluorocarbon, here we have a moderate ODP, means while hydrochlorofluorocarbon deplete the ozone layer, they have a much lower ODP than CFC, means chlorofluorocarbon. Okay. And this hydrochlorofluorocarbon still have a significant global warming potential, contributing to global warming. Okay. And this one hydrochlorofluorocarbon like R22 are also being phased out under the Montreal Protocol. Their production has been reduced and alternative refrigerant are replacing them in new systems. Okay. So this type of refrigerant, generally R22, was extensively used in residential and commercial air conditioning and refrigeration system. However, due to its environmental impact, it is being replaced by HFC like R410A. Okay, as I already discussed with you, their production has been reduced and alternative refrigerant are replacing them in new system like R400A HFC. We'll discuss that. See the third type here, hydrofluorocarbons. In short, you can say HFC. See, the hydrofluorocarbon generally contain hydrogen, fluorine and carbon, and unlike CFC and HCFC, which we have discussed earlier, they do not contain chlorine, making them non-ozone depleting. Okay, and this hydrofluorocarbon means R410A is commonly used in modern residential and commercial air conditioning system as well as heat pumps, and it replaces R22 due to its zero ODP, ozone layer depletion. Okay, ODP stand for what here? Ozone depletion potential. Okay, remember this thing. And here, what is the environmental impact of hydrofluorocarbon? Remember, the hydrofluorocarbon have no ozone depletion potential, so making them a more environmentally friendly alternative to chlorofluorocarbon and next, which we have discussed, hydrochlorofluorocarbon. Okay, so and here it also has high global warming potential. Although they do not affect the ozone layer, but hydrofluorocarbon have a high global warming potential which contribute to global warming. So due to their high global warming potential, these hydrofluorocarbon are being gradually phased down in favor of lower global warming potential refrigerant as per international agreement like the Kidali Amendment to the Montreal Protocol. Okay, and here I have discussed the application also. Now the next type is natural refrigerant. What is this? See, natural refrigerants are environmentally friendly alternative to synthetic refrigerant like CFC, HCFC and HFCs. Okay, earlier we have discussed this all. Chlorofluorocarbons, okay, hydrochlorofluorocarbon, that all will have we have discussed. So these substances naturally occur in the environment and have minimal impact on ozone depletion and global warming. For example, ammonia, widely the example of natural refrigerant is what? Ammonia, widely used in industrial refrigeration. Carbon dioxide, used in supermarket refrigeration and heat pumps. Even propane also used in a small scale refrigeration such as domestic refrigerators and freezers. Okay, so these are the some example of natural refrigerant. So now the question is, what are the environmental impact of this natural refrigerant? Remember, first thing, the first benefits of this type of refrigerant have zero ODP. Natural refrigerant have no impact on the ozone layer, and they have very low or zero global warming potential, making them highly sustainable and environmental friendly. Okay, and see the example include like ammonia, carbon dioxide, propane. Some example is given here, and I have already explained you that ammonia is generally means R717. Ammonia generally used in industrial refrigeration system such as cold storage and food processing. Okay, carbon dioxide used in supermarket refrigerant, automotive, air conditioning and heat pump due to its low global warming potential. Okay, then propane commonly used in household refrigerators and small air conditioning system we are using. Okay, so this is all about the natural refrigerant. Now we'll discuss the next topic, refrigerants properties. Okay, we'll see the key refrigerant properties. So in that, the first one is given here, global warming potential. Before discussing about this, you have to remember here we have a two critical properties of refrigerant that define the environmental impact of refrigerant are, the first one is the global warming potential and second ozone depletion potential. Okay, so let's see the first one, global warming potential. So what is this? See, in short, you can say GWP is a measure of how much heat a refrigerant can trap in the atmosphere compared to CO2. Okay, lower global warming potential refrigerant are preferred to reduce the impact of global warming. Example, R400A has a global warming potential of near about 2088, whereas R1234YF has a global warming potential less than 1. So making the latter more environmentally friendly. Okay, so here some example is given, so try to understand this. Okay, here you have to remember that higher GWP indicates that the refrigerant has a greater potential to trap heat and contribute to climate change. As a environmental regulation tighten, refrigerant with low GWP are being prioritized to reduce the effect of global warming. Okay, so these are all about the first properties of refrigerant. Now the second properties of refrigerant is ozone depletion potential. So what is this? See, ODP measure the refrigerant ability to deplete the ozone layer. Okay, a higher ODP means the refrigerant has a greater potential to damage the ozone layer. Modern refrigerant are designed to have zero ODP to prevent further ozone layer depletion. Okay, remember this point. So modern refrigerant aim for an ODP of 0 to comply with environmental regulations. Example, R22 has an ODP of 0.05, whereas R410A has an ODP of 0. So that is why here we have to prefer what? HFC. HFC stand for what? Already I have discussed this, hydrofluorocarbon. Okay, so generally nowadays we are preferring hydrofluorocarbon, means instead of using R22 we are selecting R410A because they have a 0 ODP. Okay, now let's see the refrigerant selection based on GWB, means global warming potential, and ODP, ozone depletion potential. Let's see. So here the first point is given, high GWP, high ODP means it is the worst choice. Means if you take the example like chlorofluorocarbon, CFC, example R12 refrigerant, in that type of refrigerant both GWP and ODP are very high, so making these refrigerant the worst environmental offenders. Okay, so they are no longer in use due to their detrimental effect on the ozone layer and global warming. Okay, so that is why it is the worst choice. Next, high GWP, 0 ODP is phase out nowadays. For example, hydrofluorocarbon, HFC, example R410A. While they do not harm the ozone layer, but they have a high GWP. Na? So these refrigerants are widely used today but are being phased out due to their contribution to global warming. Now the third one is given here, third condition, if suppose the refrigerant have low GWP and 0 ODP. So this is the best choice, this type. Like for example, natural refrigerant. As I discussed with you, In natural refrigerant, we have a different types of refrigerant like ammonia R717, CO2. Okay, so in natural refrigerant, this type of refrigerant have both zero ODP and extremely low global warming potential, so making them the best, the most environmental friendly option. However, some safety concern, example toxicity or flammability, must be managed. Okay, so this is the best choice. And the fourth condition is, suppose if you have a moderate GWP and zero ODP, current standards, in some of the refrigerant, for example, R32 and R1234YF, this type means hydrofluorocarbon like R32. So this type of refrigerant have become the standard modern HVAC system due to their favorable balance of efficiency, safety and environmental impact. Okay, so here you have to remember the selecting the appropriate refrigerant for HVAC system is crucial for ensuring efficiency, safety and minimal environmental impacts. Okay, so here the best choice is to go for, if suppose the types of refrigerant have a low GWP and zero ODP, so that is the best refrigerant. Okay, you can just prefer that type of refrigerant. As I given you the example also, like natural refrigerants will comes under this category. Now here we'll discuss the selection criteria for refrigerant in HVAC system. So here I will show you the some key criteria to consider when selecting refrigerant. Okay, what are the criteria you have to select? In that, the first one is given environmental impact. So first of all, just always choose refrigerant with low global warming potential to minimize their contribution to climate change, and prefer refrigerant with zero ODP to protect the ozone layer, like CFC and HCFC should be avoided as they have high ODP. Okay, so instead of that you can just go for another hydrofluorocarbon HCF type of refrigerant. Okay, so these are the things which you have to remember while doing this selection for refrigerant in HVAC system. Okay, now the second key point is given here, thermodynamic properties. So remember, the refrigerant should provide sufficient cooling capacity for the intended application. So that is why you have to select the refrigerant that allow for high energy efficiency in the HVAC system, resulting in lower operating cost and energy consumption. So here you have to consider the refrigerant boiling point and critical temperature, which influence its performance under varying operating condition. Okay, the third point is given availability and cost. So assess, first of all you have to assess the availability of the refrigerant in the local market, because some refrigerant may be phased out or limited due to environmental regulation. Okay, so you have to see the availability and evaluate the initial cost of the refrigerant along with potential future costs related to environmental regulation, maintenance and disposal. So availability and cost is also important factor while selecting refrigerant. And the fourth one is the regulation and standards. So here follow the industry standards and guidelines such as those provided by the American Society of Heating, Refrigeration and Air Conditioning Engineers. In short, you can say ASHRAE for selecting refrigerant. Okay. Then the next point is performance in different condition. Okay. So you have to consider how the refrigerant perform in different climate condition, including temperature extremes and humidity level. Now, the next point which we have to discuss here is life cycle consideration. So remember, evaluate the refrigerant's impact on the overall energy efficiency of the HVAC system over its life cycle. So for that, just consider the ease of maintenance and servicing the system with the selected refrigerant, including leak detection and handling. Okay. So the maintenance and serviceability, even the energy efficiency will comes under this category. So this is all about. Here I have shown you some key points which you have to remember while going to select the refrigerant. Now the topics which we have covered in this session, first of all we have discussed in detail about the refrigerants and its type. Then we have seen the properties of refrigerant. After that I have shown you the selection criteria for refrigerants. So this is all about the refrigerants. Hope all of you enjoy this session. See you in next one.